The energy of light is determined by the density of photons in a given ray of light. All light is made of moving photons, and the greater the concentration of photons in the light, the greater the energy. The energy of a photon is given as the energy of a single oscillation of a photon. It is calculated that the energy of any single photon is very, very little, barely 6.6 joules. Because of this, the usual way of referring to the energy of light is based on the density or concentration of photons passing through a spectroscope in 1 second of time. Every photon in the universe is identical and therefore has the same amount of energy, namely 1 Hz, which is about 6.6 joules. A joule is how we humans measure energy. Here's an analogy. A joule is like a measuring cup, and photons are like the liquid or energy that fills the cup. So in this analogy, the cup or joule is not made of the liquid or photons, but a joule can be used to measure the amount of energy. Quite simply, the energy of light is determined by the concentration of photons in the light. In other words, the density of photons determines the amount of energy that is found in different types of light radiation. An atomic bomb is an example of extremely high concentrations of photons. At the other extreme, radio waves are examples of very low concentrations of photons. In both examples, the photons are identical, the only difference being their concentration. The density or concentration of photons is referred to as the frequency of light. So the frequency of light tells you how frequently the photons roll by in 1 second of time in a spectroscope or wave meter. The greater the frequency, the greater the energy of light. For more information, go to the website deliveredonline.com. See below.